We're back. Starting at question 6. Which of the following phrases correctly describes the algebraic expression m minus 6? Okay, you're out of here. So I have this expression m minus 6. The difference of m and 6. Well, that is true. The difference, I say the difference of m and 6, I literally keep it in this order. The difference of m and 6. Just like if I was to say the sum of m and 6, it would be n plus 6. So this of business helps me put it in this order. So A is correct. B is also correct. 6 less than m. Well, here's m. 6 less than it means I'm taking away. So here's 6 less. Here is 6 less. Less than what? It's 6 less than m. So the first two are correct. C, both the difference of m and 6, that's what A says, and 6 less than m. That's what B says. So actually C is an even better choice. And notice this, which of the following phrases, which implies plural, more than one, correctly describes the algebraic expression m minus 6? There you go. These two. The difference of 6 and m would be written as 6 minus m. So that would definitely be wrong. So number 6 was C. Number 7. The solution n equals 8 is true for which equation? Excuse the typo there. That was bad grammar on my part. Well, just plugging in the 8, we can see right away that 8 minus 10 is less than 0, so that makes no sense, not 18. 10 minus 8 is 2. That doesn't work. And now we're left with 32 over m. Remember, a fraction is a division problem. So literally, C is saying 32 divided by 8 when we plug in. Does that equal 4? Well, 32 divided by 8, sure enough, is 4, just like 4 times 8 is 32. So the correct answer here was C. D, if you put in 8, you'd have 8 over 32. And here, this is a fraction which I can reduce if I divide top and bottom by 8, because both these numbers are divisible by 8. 8 over 32 turns into 1 over 4, which is definitely not 4. Number 8. Moving on. Order of operation rules. First up, let's copy the problem down. 4 to the third power. Let's get a little more room here. Minus 5 times 9 minus 7 quantity squared, all divided by 4. Well, according to order of operations, I have my parentheses, followed by my exponents, right? Then I do multiplication and division from left to right. Then I do adding and subtracting from left to right. Parentheses, I've got some. 9 minus 7 is 2. So I will do that one operation and copy everything else down. And now I will read, and what's the next thing I need to do? Exponents. So I have two exponents. I have 4 to the third, which is 64. And I also have 2 squared to the second power, which is 4. Copy everything else down. Okay, now I have multiplication and division from left to right. Well, the first I run into is 5 times 4 is 20. So 64 minus 20 divided by 4. And now I still have some multiplication and division. I have this. 20 divided by 4 is 5. So 64 minus 5 turns out to be 59. So the correct answer was C. Next up, I need to move things a little bit. Make some space. Aunt Mimi paid $33.04 for gas that cost $2.36 per gallon. How many gallons did she purchase? Okay, and notice the answers are in gallons, so shouldn't have any. She bought $14 worth, right? Because it's asking how many gallons. We know when we go to the store that the price we pay for one item times how much we buy gives us our total. So in this case, the cost for 1 gallon is $2.36. How much we buy? Well, we don't know. Matter of fact, that's my question. It's gallons. So tell you what, we'll put in gallons. So, and that's, so, but I know we paid this times how many she bought, which I don't know, but I know she paid $33.04. Well, this problem is really no different than a problem that looks like this. Say 4x equals 12, right? When I'm multiplying by the variable here, so I have to divide both sides. That will give me the variable by itself. So here, if I want to get gallons by itself, I'm going to have to divide both sides by $2.36. So I have a decimal division problem. All right, so I'm going to have to move the decimal point over 2 places. Excuse me. If I move that over 2 places, I'm going to move this over 2 places. And remember that my decimal point was right there. I'm going to move this up some. So how many 236s go into 3? None. 0. Into 33? 0. But I can get one 236 out of 330. So let me do that. Oh, it looks like I'm going to have to borrow to do this subtraction. 10 minus 6 is 4. I have to borrow. Leaves that a 2 there. To borrow again. 12 minus 3 is 9. I'll bring down the 4. So I have, how many 236s go into 944? Well, 200 times 5 is 1,000. So that's too much. So it has to be less than 5. 200 times 4 is 800. Some extra. And that's looking better because I'll have 436 as well. So I'm going to guess 4. 4 times 6 is 24. I like that. It ends in that value. Carry the 2. 4 times 3 is 12, plus 2 is 4. Isn't that convenient? Carry the 1. 4 times 2 is 8, plus 1 is 9. Well, that worked out nicely. So sure enough, she bought 14 gallons, and that actually is one of our choices. The correct choice was A here. And here at the bottom, we have simplify. Most people really got this quite well. So in this case, I'm going to add 3 cubed is 27, plus 4 squared is 16, minus 2 to the 5th is 32. So I have to add and subtract from left to right. So that's going to give me 43 minus 32. 43 minus 32 is going to be 11, which is answer B. Okay, let's pick up on where Mrs. McCabe left off. Remember, she had all these sons named Dave. Well, she did. What did she do? Oh, she named all of her sons Dave. And that wasn't a smart thing to do. You see, when she wants one and calls out, "Yoo-hoo! Come into the house, Dave," she doesn't get one. All 23 Daves of hers come on the run. Now, you have to admit, that's a lot of Daves. If you want to find out what happens, you got to stand through one more video.